Hey pre-calc. All right, so let's do our solving exponential equations notes. Okay, so remember, if the bases are the same, then that means the exponents are also the same. So for this example, in order for me to solve it, I can set 4x equal to x squared plus 3. Subtract 4x to both sides, I'll get x squared minus 4x plus 3 equals 0. This can factor to x minus 3 times x minus 1, and therefore x will equal 3 or positive 1. All right, why don't you try and pause the video, and when you're ready, unpause it and check your answer. All right, did you get x equals 2? Let's go to example 2. If the bases aren't the same, so in this case I have base 9 and base 3, then you need to rewrite them so that they are the same. So for instance, I can write 9 as 3 to the second power to the x plus 3 power, and this is 3 to the x minus 4 power. Remember, a power to a power rule says that we just distribute or multiply the power raised to another power. So I would have 3 to the 2x plus 6 equals 3 to the x minus 4 power, and now the bases are the same and I can set the exponents equal. 2x plus 6 equals x minus 4. Subtract x from both sides and I'll get x equals, subtract 6 from both sides, I'll get negative 10. All right, you guys. You try. Go ahead and pause the video and unpause to check if you got it right. All right, so you should have gotten x equals 5 over 2 or 2.5. Let's keep going here to example 3. All right, 1/6 x plus 2 equals 36. Now I'm going to rewrite both sides. So 1/6 can be rewritten as 6 to the negative first to the x plus 2 power, and 36 can be rewritten with a base of 6 to the second power to the 2x minus 1 power. So I've got 6 to the negative x minus 2 equals 6 to the 4x minus 2. And I can set those bases equal. Negative x minus 2, the exponents equals, not the bases. All right, let's add x to both sides. Add 2 to both sides, we get 0 equals 5x. When I divide by 5 on both sides, x equals 0. All right, let's move on to example 4. I'm going to rewrite both of these problems with base 2. So 4 can be written as 2 to the second times x plus 3, and 8 can be rewritten as 2 to the third times x minus 3. Distribute out. 2 to the 2x plus 6 equals 2 to the 3x minus 9. Now the bases are the same, so I can set the exponents equal. 2x plus 6 equals 3x minus 9. All right, subtract 2x from both sides. X equals, if I add 9 to both sides, 15. Nice. All right. You guys go ahead and try, pause the video, and when you're ready, check your answers. All right, did you get x equals 1? Let's move on. All right, this is a little trickier. So how can I work with this? All right, I notice, or I should notice, that 27 over 64 is the same as 3 to the third over 4 to the third. So I can rewrite that whole fraction as 3 over 4 to the third, which is equal to 3 over 4 to the x. And now I have equal bases of 3/4 on both sides. So x equals 3. So sometimes these things can be kind of tricky. You just have to think about how can I rewrite them. Okay, so what if you can't make the bases the same? Like what if it doesn't work out perfectly like it did right there? Okay, remember, log base 2 of 2 is 1. Log base b of b, these cancel out and I get 1. So if you can't make the bases the same, what are you going to do? You're going to take the log of both sides. Be careful, because in order to do this, you need the base by itself before you can take the log of both sides. All right? Let's check. Okay, over here, there's no way I'm going to get 3 and 13 to be the same base. So what am I going to do? I'm going to take log base 3 of both sides. Okay, so these are going to cancel out, and I'm going to get 2 minus x equals log base 3 of 13. Okay, and remember, I can use what's called our change of base formula to figure out what this value is. All that is this log of 13 over log of 3. So I can put that into my calculator and get out a value. Try that now. Log of 13 divided by log of 3. Always log of the base goes in the denominator, the larger number goes in the numerator. Not larger than value, larger than actually the bigger one. And you should get out 2.33. So now I've got 2 minus x equals 2.33. All right, subtract 2 from both sides. I'll get negative x equals 0.33. And when I divide by negative 1, I get x equals negative 0.33. All right, your turn to try. Pause it, and then when you're ready, see if you got it right. Did you get 0.86? All right, let's go to the next one. All right, so here I have to make sure I get the base by itself before I do anything. So we're going to subtract 7 to both sides, and I'll have 1/2 e to the 2x minus 1 equals 7. Multiply by the reciprocal on both sides. So I've got e to the 2x minus 1 equals 14. And now, in order to cancel out that e, I'm going to take the natural log of both sides. I'll be left behind with 2x minus 1 equals the natural log of 14. Okay, cool. I can just put the natural log of 14 in my calculator and figure out what that is. It's approximately 2.64. So now I have 2x minus 1 equals 2.64. I add 1 to both sides. I get 2x equals 3.64. And when I divide by 2 on each side, x is approximately 1.82. So remember, natural log is just a button on your calculator, and you can just put 14 in and get that value. All right. You guys try on E. Why don't you pause it and then see if you got it right. Remember, you need to keep the base completely by itself. Get the base completely by itself before you can start taking a log of any side. Did you get negative 3.774 approximately? If you didn't, take a second to check. All right, let's figure out what to do with this problem on example 9. Remember, this is just over 1. So we already talked about solving rationals before. Let's cross multiply. We're going to have 300 equals 235 times 2 plus e to the negative x. All right, let's start solving this thing. Let's divide both sides by 235. And 300 divided by 235 is approximately 1.28 equals 2 plus e to the negative x. I'm going to subtract 2 from each side. Is negative 0.72 equals e to the negative x. And now that I've got that going on, I can natural log both sides because e is by itself, the base is alone. Okay, I have got negative x equals natural log of negative 0.72. I can just put that in my calculator. Natural log negative 0.72 is going to give you an error of non-real answers. And remember that this negative value is outside of the domain of a logarithm. So that value has to be greater than 0. Since it's not greater than 0, there is no solution. That is an undefined value. It is not going to work for this problem. Okay, we cannot have a negative inside there. All right, you guys, we've got some practice problems. Let's go through them together. All right, you guys, so we have some practice problems here. Let's get started. On number 1, they have the same base, so let's set those exponents equal to each other and solve. I'm going to pause and let you guys check your answers when you're done. Did you get x equals 2? Yay! All right, for the next couple of problems, you need to, problems 2, 3, and 4, you'll notice that you have different bases, but we're capable of rewriting them as each other. Okay, 2, 3, and 4, I'm able to rewrite the bases as a common base. So try examples 2, 3, and 4, and then come back to check your answers. All right, you guys, so let's check our answers. Up here, we should have gotten x equals 3 with a common base of 2. Up here, we should have gotten a common base of 4 and gotten x equals negative 1/7. And up here, we have a common base of 5 and gotten x equals negative 3/5. All right, so let's move on to the next couple problems. We're going to have to be right here in these next few, taking the log of both sides. So let's practice numbers 5 and number 6, getting the log on both sides, taking the log of both sides, and solving for that x. So why don't you pause it, do 5 and 6, and come back and check your answers. All right, so for number 5, we should have gotten x equals 5. And for number 6, you should have gotten x equals 2.21. All right, and the last couple, 7, 8, and 9, you have to do some solving to make sure that the base is by itself first. So we need the base alone before we can log both sides. So move things away, isolate the variables. So try out 7, 8, and 9, pause the video, and then check to see if you got your answers right. All right, you guys, so you should have gotten x equals negative 0.59 for number 7, number 8, 0.09 approximately, and number 9, approximately 4.39. Okay, last one, we have that like a rational type situation going here, so make sure you cross multiply first and then go ahead and solve. Pause the video, last one, then check to see if you got it right. All right, you guys, and you should have gotten for number 10, no solution. Feel free to go ahead and take your time, go back and look at any examples that you need to, pause the video, and we will go over any questions you have tomorrow in class. You do have homework tonight, so make sure you go see what that is in the book. Bye.